What's up, peeps? Today we're going to talk about this VF2SS that we just got placed in here, and some things you should consider when maybe putting a VF2 or any medium-sized or upper-sized Haas machine, or I guess really any VMC or lathe or whatever tickles your fancy. So yeah, this is, let's just talk about the space really quick. I do the typical apologize because we're moving things kind of spiel, but yeah, that's what's going on. That's why it's a mess in here. So this is a 1100 square foot, well it's a little closer, it's 1160 square foot garage behind the house. 12-foot ceilings, basically to the joists. And yeah, so that's kind of advantageous compared to most people because I have full 9-foot doors. So getting the VF2 in here is really easy. When it comes shipped, the head is actually lower. It's closer to the height of the side mount. But I'm not entirely sure what the actual max shipping height is. I know, like, if you have like 10-foot ceilings, 10-foot or 9-foot ceilings, I think you can get away, 9.5-foot ceilings, I think you can get away with having the shippers pull covers off the top and it having to be rolled in. But we actually had enough height with 9-foot doors to be able to have the forklift just roll in here. I thought they were going to have to come in here, open the door, and skate it, but they actually, all this stuff that's spread out was actually placed in this corner, so that's why now it's all everywhere. And they just, because it was placed in the corner, they just brought it in here. We took it off the pallet in the driveway. They brought it in here on a fork, and they drove it into place, basically. And we measured off the back of the wall, and that's how we got, we measured off the back of the wall, and then they pushed it with the forks, and then, yeah, then we sat it down, and they, left it basically, and then eventually Haas came and leveled and did all that kind of stuff. So yeah, it's one of the important things is obviously the height. Now, that is not something I've had an issue with, obviously. My issue has actually been power. So the VF2, the SS version, the data plate on the back here lists a full, it's kind of weird how it lists it, but it says full load 70 amps, where its largest load is 65 amps. And I'm going to guess that 70 amps is like the 70 amps is probably like the initial ramp up, or like maybe a full, like a 200% cut. And then whereas like the 65 amps is probably a continual, like maybe 150% spindle load on the meter kind of cut. And that's not single phase 70 amps. It's actually, that would be 3-phase 70 amps, which would actually be a lot more single amperage if you're trying to phase convert, like generate a leg, the last leg you need. Because I'm in a residential and I have single phase coming into the panel box, and I only have single phase 100 amps. So basically, here's how this whole system is running. There is 1/0 gauge coming from the house to this sub panel, and in this sub panel is a 100 amp breaker. The machine is running on a 60 amp breaker, a single phase breaker, so 2 hot legs on the ground. The hot legs go up conduit, well, with the ground, and all the way across, lazily put right against the insulation, which is probably not to code. Definitely to code, I mean. And then those 2 legs, oh, they're a 2 gauge wire, come into this disconnect right here, and it's 60 amp fuse. So you got your two hots, the ground, bonding bar, ground, and the 2 hots. And the ground is a 6 gauge, which is obviously undersized, but the conduit also acts as a ground when properly installed. We got that going. And then we have the two hots go up, well, the ground too, up into the, it's a phase perfect PT355 with the digital readout, and it comes into here, the two hots and the ground get bonded together, and basically you can see a manufactured third leg comes out on T3. Super easy to wire if you were worried about doing one yourself. But my problem is when you have, here, hold on. When you have this loaded up, it'll give your input power. And currently, I have basically 230 volts coming in from the street. So from the overhead lines transformer, everybody shares kind of a transformer typically. My arm's getting tired. So you have a transformer, and yeah, so I get 230 volts basically off the street. The best I've seen is like 232, and your kind of voltage input is going to vary depending on where in the world you are. But this machine wants 240 if you're running it like standard transformer. They have a high volt 400 volt or 480 volt transformer that you can opt for. Obviously, if you're in a commercial area and that's the only power, blah, blah, blah. So basically, 232, 230 coming down the line. So our house is probably I think I counted, it's like the 10th house on the transformer, which is not that good, because what happens is your neighbor has their air conditioner on, right? And an air compressor, or the condenser on the air compressor, on the air conditioner, takes a lot of power. So what happens is on startup, or even when it's running like a full load, when it's warm out, it takes a lot of, I'm not an electrician, so I can't explain it. But basically, if everyone's running their air conditioner, the final voltage we get out down all the line is, I've seen as low as 225. So actually I've seen 222. So obviously that's not like low, and that's within the specs for the Haas. But the problem is, when you do a spindle ramp up, basically this is a 12K spindle. If I ramp the machine from 0 RPM all the way up to 12K, even if I ramp it to 7K, it'll actually dip the incoming line voltage all the way down to, the worst I've seen is 184, and 184 is below the safety cutoff of the VF2 SS. So what happens is, I believe it's 190 volts. Under 190 volts incoming, the machine just shuts off. So I have that issue sometimes. So when it does a tool change, it does full rapids, even 50% rapids, the coolant pump's on, the auger's on, and the spindle ramp up, and I have 224 coming in line, it'll sink that power all the way down below 190 and kill the machine. Now, what I have to do is put the rapids down to like 25%, and I can still get it to ramp all the way to 12K from 0, as long as I have 230 coming in. And you can actually see, like, we're going to start the phase converter here in a second, but you can see the input on the phase converter, the words, and yeah, so basically if I have 230 coming in, that's enough upwards voltage to, like, it won't dip down to 190. It dips down to like 205, I think. And at that point, what happens is the machine actually throws a low voltage error, but only for the seconds that the ramp up is happening. And after that, when you have low spindle load, like you're cutting aluminum, like 60 series or something, and you have like a pretty regular cut going on, maybe like 20% load, 30% load, there's no problems, because the voltage isn't, it's not pulling there's no big demand. So that's kind of something to keep in mind if you want to run a VF2SS. Now the normal VF2, which was something we were actually looking at, the normal VF2 might be okay. I don't know if the super speed with the 12K spindle, or maybe even the 10K spindle, I don't know if, because the super speed is supposed to have a faster ramp up time, maybe that's what's causing the actual the issue, because it sinks voltage hard. Obviously, it's pulling a huge load, I guess, from what I can understand, when it tries to ramp that quick, because basically you're commanding a spindle from 0 to 12,000. It's going to suck as much power as possible getting to that commanded speed. That's the way I look at it. I'm obviously not an electrical engineer, or really anything. I'm just someone with enough knowledge to be incredibly dangerous to myself. So what I'm going to do is I'm going to start the phase converter. I won't talk about the phase converter at all. I'll probably do a separate video on my experiences with that. Not necessarily good experience, but it does what it's supposed to. And then I'll show you the issue. It's really not that warm out today, so what I'm thinking is we probably have like 228 to a little over 230 volts, probably incoming line, and you won't see the issue that I'm talking about, but well, you will actually see it. The lights dim when I do a spindle ramp up. But yeah, just we'll go over that, and then yeah, we'll go from there. So, phase converter. Pop this guy on. That'll turn on. Yeah, 228 is what we got. Yeah, 230 on the generated leg. So that's really all the noise that the phase converter makes. It does actually make a higher pitch buzzing noise on load, like you can hear the load change. But really, honestly, compared to like a rotary, it's not annoying whatsoever. You really get used to the sound. It probably sounds pretty bad on camera, like when you guys were close up to it. But yeah, it's really not that bad. Like up here, you can barely hear it. So it kind of gets drowned out, especially drowned out by like the compressor turning on. So we'll wait, and then I'll film an actual, I'll do like the spindle warm up, and then I'll film it like ramp up to like 8K or something, and I'll show you what actually it displays. So yeah, we'll get to that. Sweet. 120 spindle for the warm-up program. Let her rip. Let's actually talk about the machine and the options, and maybe why I went with a VF2SS as opposed to VF2 regular, or maybe like a TM style machine. So basically, I have a TM 2P at work, bare bones, absolutely nothing on it. I have the manual offset, no auger, nothing. The only thing that's on it, yeah, actually it's bare bones. So it's just the TM 2P, whatever options you get with the 2P, I'm not too sure. So that's what I run at work, and it's a good machine. It's I've cut steel a couple times with it, some pretty hard tool steels, and 304. That was quite the novice experience. I tried to cut 304 with a half-inch cutter, half-inch or maybe a three-quarter cutter, and it was pretty vibraty, pretty bad for the cutter. It destroyed the edges on the cutter, obviously. So that, I don't think the machine's not, a TM 2P is not very rigid. It's not as heavy as a casting as like the VF2SS. I think the TM weighs around 4K, 5K, whereas the VF series, like a 2 weighs in the 7K plus, close to 8K, I think, is what this weighs. So that's good on a rigidity standpoint as far as like cutting steels. Mild steel's obviously easy, but just that was one of the considerations, was rigidity. I never know what I'm going to cut. I'm trying to do like job shop work right now, so kind of like zometry, that kind of stuff. So you never know what kind of comes to the door. So we did VF2 was kind of one of the factors for that. The VF2SS is fast, so I wanted to try to run lights out in the future when I had all the tools set up. Just kind of future proofing for the cost of what's the word? I would say the ROI is better on a VF2SS compared to a TM2P. Plus, when you fully load, like fully option out a VF2SS compared to a TM2P, the difference is not extraordinarily high. They're within I don't really, they're within 20 to 30K. In fact, they're probably closer if you go with the standard options like the probe and the auger, and really the two kind of base ones you want. And so that was kind of, I know I'm kind of rambling, but those are kind of the deciding. That was kind of the deciding factor, was the growth aspect, where if we started to really make money with the machine, you don't want to regret not having a bigger machine when you've already gone through the trouble of getting it rigged, getting it shipped, paying for it, financing it. I mean, the bank is financing it, so it's the monthly payment is not significantly more for the what you're gaining. I mean, the side mount tool changer by itself is absolutely insane as far as speed, and then just the fact that if you get a 20 ATC on the TM2P compared to the 30+1 side mount, I mean, you're gaining 10 tools, and having the tools already loaded in there, set up in Fusion, it's just it's better, I think, for job shop type stuff. Anyways, if you have a product that you have a line of tools, you have 10 tools you use, and the code's there, and like the process, and it's aluminum, then maybe this wouldn't be such a good idea. I'm not too sure, but that's kind of where I'm at for the deciding factor kind of thing. So I guess now we'll talk about the options I went with and why I went with them. So this VF2SS is pretty well kitted out, I would say. Regular coolant system. I've had the high pressure, the T, put in, but it doesn't have through spindle just because I can't afford through spindle tools. So I figured future proofing it by the things that cannot be field installed. So that can be field installed in the future. You just get a bigger pump, and they do something with the T, I guess, for through spindle. So yeah, regular 50-gallon tank, regular coolant pump, flood coolant. Didn't go with the P-Cool. I didn't go with P-Cool because I ended up getting a fourth axis, a rotary, and I thought the rotary would get in the way of the P-Cool nozzle. And some people did talk about that, like on the forums, when you look it up. That is kind of a consideration. The P-Cool would be nice, but I didn't think it would be worth it for my application, I guess, with the rotary. So yeah, obviously the rotary with the fourth axis wiring. I'd love to have gotten the fifth axis wiring for future proofing, but that can be field installed. So just fourth axis, HRT 210, bare bones. The auger, we got the chip auger. Obviously the side mount. The side mount, I think, is very worth it compared to the ATC. Alright, hold on. Alright, sorry about that. The compressor kicked on. It's pretty loud, it's in here. So like I was saying about the side mount, I think the side mount is worth it in comparison to the Carousel 20. The speed is crazy on the side mount, especially the new side mount where it's not on a, it doesn't have the individually indexed pockets. It's fast. It's really cool actually to watch it actually go. And like, if I got a tool that's in like pocket 30 up at the top, and then pocket 15's at the bottom, and I call for pocket 30, it whips that thing around like pretty fast, obviously. So side mount I think is pretty worth it for, yeah. And next I got whips, obviously, with the probe. So super, if you're gonna go through this trouble and you don't get the probe, you're on something, because it is, I've never used it, and I only use it, like I've been using it obviously for the last month I've had the machine, but it is so worth having the tool setter and the probe. The probe's obviously in the mount changer with the optical. It is without a doubt one of the greatest things ever. If you buy one of these modern day CNC machines without a probe, you're wasting a lot of valuable time. It's just, I haven't done any of the fancy stuff you can do, like part checking or like tolerance checking, any of that kind of like error out kind of stuff. None of that stuff. I haven't even used it yet for the fourth axis because I'm still working on kind of like a fourth axis plate, but just doing simple 3-axis regular milling, like measuring tools with the wear offsets and the probe finding corners, like webs and bores and stuff, it makes it so easy. I mean, I was working on this adapter plate for that 4-jaw chuck, and the adapter plate itself's not that great. I have to redo a couple things, but just like, how would you find a bore? I mean, to find a bore normally, you're gonna have to get your indicator, indicate all 4 sides and everything. Where it's like that on the pocket, it's just so easy to do, to indicate a bore in with the probe. I mean, you tell it the approximate. Well, you guys know. You tell the approximate size, and it indicates it in. It's too easy, really. So yeah, and other than that, it's a VF2SS. It's quick and it cuts metal. And yeah, this thing's got 60 seconds left before it switches. So I'm gonna film this voltage problem I'm having when this thing gets down, and we'll talk about that and maybe some solutions if you guys are having problems with it, because I couldn't possibly be the only person in the world to run into this problem. But it certainly seems like it every time I do a Google search about it. It's been a learning process, this electrical issue I've been having. So let me, we'll wait for this thing to switch over. So what we're at right now is, we're at, hold on, 6,000 RPM, 3% spindle load, 20-second dwell. Here's the voltage, 350. All right, we got 15 seconds. Now, here is the lights, and I'll show you 10 seconds before it ramps up. So it should ramp up to close to 8K, I think. Yep. So it did that, and then it gives you a low voltage. I don't even know if you guys saw that. A quick low voltage error, and then, yeah, 9K. And this is actually good compared to yesterday, where we had 225 incoming line, and I couldn't even run the machine. When it got to 9K, it actually shut off because of that low incoming line. It's kind of, it's a really annoying problem, because a machine that isn't process reliable is almost a machine that you don't want to use. I have to, if I know that it's going to be warm out and my incoming line voltage is going to be low, then I have to babysit the machine or do option stop on every tool change, which is kind of defeating the point of having a 30 mount side tool changer with the speed of the SS. So yeah, it's annoying with the process reliability. I'm working on some solutions, and why don't we talk about some solutions if you're like me and you run into this problem. So here's initially what happened. In the walls, I have 8 gauge wire because I was running 50 amp welder outlets. So I had 8 gauge 2 power wire and a ground already coming from the box up above the attic and going to the wall. So we tried that, and that didn't even let the spindle ramp up to, it would not get to 12K. You couldn't even slowly ramp it up there. If you slowly ramped it, it would actually kill the machine. So what I am doing was I got 6 gauge wire, and I test ran it like from the box just on the ground to the disconnect, and that alleviated some problem, but our incoming line would still drop pretty low. So eventually I was like, well, I gotta try everything, and I went and got 2 gauge wire, and that's what's now up in that pipe and that conduit. And the 2 gauge only added a couple of volts of like cushion, kind of. Going from 8 gauge to 4 gauge was I thought was going to solve the problem, but it was just, it just alleviated some of that choke that the line would suffer from. So I figured, okay, well, maybe if I go all the way down to 2 gauge, that'll be enough to not choke out that demand. As I was saying, 2 gauge wire is rated for like 115 amps at its proper heat rating. So obviously that's way over, well, it might not necessarily be way over, because like I said, that 70 amps is actually 3-phase. So that's something to keep in mind. But that should have been enough to alleviate my problems. And then I kind of ruled out that it's probably not the breaker size because it never blew a breaker. I bet the machine would actually blow the breaker if you went like 150% spindle load, or maybe 200% spindle load for a couple minutes or seconds, maybe 15 seconds at 200%. You'd probably actually pop the fuse, just because, like I said, it's single phase, but it's a lot more. The single phase needs to be a much higher amperage rating than it is single phase, triple phase, three phase. Anyways, now there's a couple more solutions. There's one thing I'm going to try. So I have this buck boost transformer right here. This little guy is supposed to be good up to 64 something amps, single phase. So I'm going to put it on the single phase line, and then obviously it'll go to the converter. It's cheaper to buy a buck boost single phase. This one is a boost from 229 input to 240. So boosting it up to 240 should actually give us a wider range of that area we need before it ramps down. I hope, to make it reliable enough anyways. So there's that option. I don't know if it's an option yet because I have yet to install it, but I'm going to install it today or tomorrow. And then there's also something that would definitely work, is an AC, like a capacitor bank. So the capacitor bank would actually suck the load from the machine or from the converter, and like dampen the load kind of. I mean, that's what a capacitor does, smooths loads out, I think. So there's that option too. So you could get a capacitor bank that maybe holds that load for whatever X amount of seconds you need, and I literally would only need probably 4 seconds of that, like a capacitor bank to actually hold. But yeah, those are two options you could do. If you're having my issue, definitely up your line size. Yeah, other than that, I mean, like if the power company changed our road transformer to a bigger one, that might alleviate some problems, because actually in the house with the machine not even running, my lights dim from my neighbors turning their things on. So obviously that means that our road transformer is kind of undersized. But yeah, there's that option too. Bug the power company and tell them your new mini split system has a humongous condenser on it, so you need big power. So yeah, if you've made it this far in the video, thanks for watching. There's definitely more to talk about this kind of issue, and I'm definitely gonna remember some things I should have talked about on camera, but I'll maybe talk about them in a later video. This video is probably long enough. And yeah, sorry it's kind of a boring video, but if you're actually interested in getting a VF2SS and tossing it in your garage, this info is kind of important, and I kind of wish somebody would have told me. See, not necessarily, I mean, the info's out there, but you don't really know you're gonna have this kind of problem until it's actually installed. So yeah, like I said, some next videos will probably be a little more interesting. I have some cool things coming down the pipeline, obviously, with the CNC, some fusion stuff. And yeah, if you like this kind of stuff, feel free to sub, do all that kind of stuff. And yeah, I appreciate the view, and enjoy your weekend. All right, bye.